Okay, so we are talking about describing graphs today, guys. So you do not have to learn a new graph today. Instead, we are learning how to describe a graph, and yeah, there's a lot of things you can say about a graph. And so today, your goal today is to know when you see the directions describe the graph or describe the distribution, you know exactly what things you need to hit, okay? You know exactly what things you need to hit to describe the graph. All right, now when I say describe a graph, specifically I'm talking about numerical univariate graphs, okay? Univariate numerical graphs. So like histograms, dot plots, stem and leaf plots. These are the graphs that you will be asked to describe. Okay, so you are gonna need to hit 5 things, all right? You need to hit 5 things when describing a graph. The first one is symmetry. The second one is mode. The third is unusual features, like outliers, gaps, things like that. Center is the fourth, and the last is spread, okay? Symmetry, talk about mode, talk about unusual features, talk about center, and talk about spread. So put those together and just remember the acronym SMUX. Okay, just remember the acronym SMUX. All right, I think there's like a peanut butter jelly thing, like Smuckers. You guys know what I'm talking about? I don't know if that's the right word, but SMUX. All right, so that's your acronym for this. All right, so yeah, so on your notes, I think you guys have that acronym SMUX, but I don't have the words there for you. So go ahead and write in what each letter of SMUX stands for. Okay, symmetry, mode, unusual features, center, and spread. All right, so let's just go through each one. So starting with symmetry, okay? Symmetry, like if you look at these 3 examples, the last one is very symmetric, but the first 2 are not. Those are considered skewed, okay? So for symmetry, basically it means that if you can fold the graph in half and they match, right, that's symmetric. I think you guys understand symmetry, right? Know that in stats, it doesn't have to be perfect though. Like this example right here, it is not perfectly symmetric. It's just pretty close to it. So we'll call this, you know, approximately symmetric, and that's okay. In stats, if it's close to being symmetric, that's good enough. That's good enough. Okay. And if it's not symmetric, typically it's going to be one of these 2. It's either going to be skewed left or skewed right. And you want to specify that, if it's skewed left or skewed right. How I remember which one is which is I think about following the tail, okay? So for skewness, follow the tail. So for this skewed left one, the tail is on the left. And skewed right, the tail is on the right. All right, so just remember to follow the tail. All right, so that hits symmetry. So you're either gonna have something that's roughly symmetric, or it could be skewed left, or it could be skewed right. Okay, and that is the first letter in SMUX. All right, the second letter is talking about mode, M for mode. Sorry, I'm kind of going out of order in your notes right now. We're going back to the top, okay? The bottom half was symmetric or not symmetric, and now we're back on the top half. All right, mode is just talking about like how many peaks are there, right? How many peaks are there? So if you have one main peak, kind of like these two guys have one main peak, those are considered unimodal. Uni, one, modal, mode, so one mode, unimodal. If there are two peaks, this is considered bimodal. And if there's three or more, we call that multimodal. Sorry, there's no trimodal, okay? It's just multimodal. All right, so for example, if you guys were to look at the histogram to the left or on the PowerPoint right now, what would you consider this one? Anyone want to give it a shot?
Bimodal.
Yeah, good. Yeah, bimodal, perfect. So yeah, notice that, you know, this peak on the left isn't as tall as the right one, but that's okay. It doesn't matter who's the tallest. It's just in general, it peaks twice. All right, in general, it peaks twice. So that is considered bimodal, bimodal. Great job. Okay, and then just in case you run into this kind of more unusual situation, but sometimes, if you have something that doesn't really have a peak, it's just kind of like the same level across, this is just called uniform. Okay, it's just uniform across. So there's no like one obvious peak. Okay, and that is our second letter in SMUX. Okay, any questions so far? All right, flip to the back of your notes and we'll continue. All right, so we have SMUX, symmetry, and mode so far. We're gonna skip unusual features. We're gonna save that for the end. And we're gonna go to C, which is center. All right, so for center, right now, I just want you guys to discuss where the middle of the data falls. So just kind of like eyeball it at this point. All right, just eyeball it. So kind of like with these graphs, graph A, I would eyeball to be about 67. Graph B, I would eyeball to be about 77. Graph C, I would eyeball to be like 86. Okay, so just kind of roughly eyeball it for now. And in the future, in chapter 4, so in the near future, we're gonna specifically measure the center using the mean and the median. Notice not mode. Mode is not a good measure of center actually. So mean and median we're gonna do in future chapters. But for now, we're just gonna eyeball it. Now, be careful here, guys. When I say, tell me an eyeball kind of where the center is, please, please, please always give me one number. Okay? Give me one number when you kind of estimate that center. Do not tell me the center is around 60 to 65. Don't give me a range there. Give me one specific estimate for that center, okay? So one number for center. All right, and then the last S in SMUX is spread. Okay, so spread is just how consistent is it? Is it super stretched out or is it super compact and very consistent? Okay, so we want to talk about spread. So spread, discuss how spread out the data is. It refers to the variability in the data, right? Is everybody really, really consistent or is it a wide range? So 3 measures of spread. We have range, standard deviation, and IQR. The last 2 we're going to talk about in chapter 4. So don't worry about those for now. For now, I want you guys to tell me instead, for spread, tell me what the range is. All right, just tell me what the range is. And the range you calculate by taking the maximum value and the minimum value and subtracting them. Okay, so if the lowest value is 10 and the highest value is 50, the range is 40. Okay, please, again, do not give me the range goes from 10 to 50. No, don't do that. Tell me that the range is 40, that difference. Okay, so one number for center, one number for spread. All right, any questions on center or spread? Okay, hopefully that's pretty straightforward so far. Center, you're just eyeballing it, and spread, you're giving me the range. Okay. All right, now the last letter is just unusual features. All right, so anything strange that is happening in your graphs, like these outliers, you would want to mention. You're like, oh, there's a low outlier at 50, and there's a high outlier at like 90. And an outlier is just a value that lies far away from the rest of the data. You can mention any gaps in the data. If you see like, oh, there's no data between this number and this number, okay, you can mention those. Or there's like clusters. There's like, oh, there's a small cluster in this area, and then there's like, the rest of it's here. Okay, so these are things you want to mention if they are there. If they're not there, you don't have to say anything. Right? You don't have to say there are no unusual features. You don't even have to mention it. Just if there is anything interesting, mention it. And that's it. All right, and that is SMUX. Okay, so SMUX, we got symmetry, mode, unusual features, center, and spread. Okay, symmetry, mode, unusual features, center, and spread. Any questions on SMUX? All right, we're gonna do some examples so you guys can kind of see what that looks like. But before we get to an example, I have a question for you guys, okay? My question for you guys, kind of as like a side note, is go ahead and read this sentence to yourself. Okay, just read it. Hopefully it looks familiar. You probably have seen it before. And I'm actually curious, what do you guys think this sentence means? What do you think this sentence means? Okay, so anybody, go ahead and just tell me, what do you think this sentence means? Mary had a little lamb.
Mary has lambs that are small.
That are small. Okay, so let's flesh this out a little bit. So Cassidy, who's Mary? Like in your head, who is Mary? What are you picturing?
A girl.
Okay, so Mary's a girl, and she has a little lamb. She has like a little sheep thing, right? Am I right? Okay, so I'm, excuse my drawing. I'm gonna try to actually draw this out, guys. Please don't laugh too hard. Okay, so we have Mary. Okay, I'm gonna give her long hair. Kind of like our Mary. And she's like a shepherdess or something, or she like owns a farm, and there's the tail. Okay, some ears. Okay, so there you go. There's Mary, and she has a little, hey, that's not bad. She has a little lamb. Okay. Can somebody give me a different interpretation of this sentence? What else could it mean?
She had a little lamb, like it's dead.
Oh.
I don't mean to be so morbid. It's just like, it depends on like what word you put the emphasis on.
Oh, that's a good one. Like Mary had a little lamb. Okay, so is there a copy paste function on there? Let me see if I can copy, paste. Oh no, I can't. Okay, so another interpretation would be Mary. Let me draw her again. Sorry, Mary, this is not you, okay? You are better looking than this. Okay, so Mary, oh boy. Had, there's the feet. All right, Mary had a little lamb. Oh gosh. Okay. So that's another, okay, maybe Mary shouldn't be smiling. No, okay, there we go. Okay, any other interpretations that we can have? Good, Mary had a little lamb. Any other ways you guys can read this? Mary had a little lamb.
Can you eat lamb meat?
Yeah, lamb.
Like she had it for dinner.
There you go. Yeah, last night Mary had a little lamb for dinner. Yeah, a little bit of cherry sauce, you know, side of potatoes. So yeah, another interpretation could be that Mary, let me do a little plate here. Okay, that's a plate. And I don't know what lamb chops look like, but I think they usually have like a bone. There's the meat. Here's the fork. Here's the knife. And Mary sorry, that's supposed to be drool, had some lamb. All right, she ate some lamb last night. So Mary had a little lamb last night for dinner. Yeah, nice. Okay, there's like one more interpretation I think you can have from this. Let's see if anybody can get it. Mary had a little lamb. You guys want a hint? What if Mary wasn't a person?
Oh, maybe
Mary's a
Mary's like
lamb?
a mom and had a little baby lamb.
There you go. Yeah. What if Mary is actually a sheep? All right. And Mary's a mom sheep. There's Mary. All right. There she is. Alive and well. And then she had a baby lamb. All right. All right. And there's the baby lamb. Okay. There you go. Hey, that wasn't too bad. Okay, except the Mary eating dinner one, that looks crazy. All right, so that's kind of crazy actually, that if you guys look at this sentence, right, look how many different ways you can interpret this one very familiar sentence. And look how different the interpretations are. It's crazy, right? So this is just to show you guys how important, let me put this in red and make the font very big. This is just to illustrate to you guys the importance of context. Okay, the importance of context. Because without context, you are able to interpret the sentence however you want. And I don't know about you guys, but have you ever been like misunderstood? Right? Have your words ever been taken like out of context? I think all of us have experienced that, right? Like just being misunderstood, or maybe you were like texting and you know, you can't really get tone, and so people might misread something that you meant to be like sarcastic or funny and like got offended by it. You know, there's so many different things. So context is so important because that tells you how to interpret sentences, right? That gives you a framework in which to interpret things. So context. Now, the reason why I'm talking about this so much is because I wanted to illustrate the importance of context when you describe your graphs, right? When you describe your graph, context is super important. All right, so just make sure that when you guys do these descriptions, answer it in context and make sure you do it in complete sentences. Okay, all right, seniors going to college soon, complete sentences. Okay, all right, let's go ahead. Let's finally do some examples. Okay, so what will this look like? So here we go. Some examples, how to describe these histograms. So we're going to compare the following distributions for female and male heart attack patients. I'm going to do the top one, and I'm going to have you guys practice with the second one. Okay? All right, so this is how it is done. And let me make my font smaller so as not to scare you. All right, so going through SMUCs in context. First off, I start with context. All right, so I start with context because I want to just kind of get it out of the way, get it done and taken care of. So I'm going to start with, oops, sorry. Come on. Sorry, let me pick my font to be a little bit bigger. All right, so to describe the top graph here, I'm going to say the graph of the ages of female heart attack patients is, okay? So get the context out of the way first, okay? Just get it done with. So the graph of the ages of female heart attack patients is, and then I'm going to go through SMUCs. So starting with symmetry is skewed to the left, right? Tails on the left, so it's skewed to the left. It's unimodal. Okay. There are no unusual features, no outliers, no gaps, so I'm not going to mention anything. Centered at about like 75 years, and has a range of, let me see, it's going from 100 to about 30. And that's it. All right, and that's SMUCs. Symmetry, mode, no unusual features, center, and spread. And that's how it's done. One sentence, and you have it all. Okay, any questions?
You know how this graph doesn't have any unusual features?
Mhm.
Do we need to say like no unusual features, or can we just like leave that part out?
Right, so if there are no unusual features, you don't have to mention it.
Okay, got it.
Okay, any other questions? Okay, go ahead and you guys try it with the second graph. Does anybody need more time? Okay, all right, let me call on somebody and see what you guys got. All right, let's see, Nick. Nick, what did you get?
I thought my mic was on, my bad.
Oh, no worries.
The graph of the ages of male heart attack patients is skewed to the left. How do you pronounce it?
Uh,
Modal?
oh, unimodal. Okay, skewed
Yes.
to the left. You said unimodal. Okay, keep going.
It's centered at, hold on, let me see real quick. I said 70. I'm pretty sure that's around like estimate. And I wasn't sure how to do the range.
All right, range, you just take the maximum value and you look at the minimum value and you find the difference.
Oh, let me do that real quick. Hold on. Is the maximum 95?
Yeah, about 95.
Nice. 70.
Nice. All right.
Change is 70.
I agree. Yeah, the range goes from, yeah, it's like 95 minus 25, so 70. All right, great. So you have context and you hit everything in SMUX. There's no unusual features, so didn't have to mention it. I think the only thing that some people might have slightly different than you is the skew to the left. Did anybody say symmetric? Yeah, some of you? Okay. So I think you can make an argument either way. There might be a slight skew to the left, but it's like so like it's like not even quite there. I think it actually leans more towards symmetric. So I'm gonna say approximately, or you can say roughly symmetric for this one. Because I think it definitely leans closer to symmetric than it does to being skewed. So that's what and everything else looks perfect. So the graph of the ages of male heart attack patients is approximately symmetric, unimodal, centered at about 70 years, and has a range of 70 years. Nicely done. Now, guys, notice how many points are in this one problem. If you have 1 point for each thing in SMUX plus context, that is 6 points in one sentence, okay? It's jam-packed. So make sure you have all 6 of those things in that sentence. All right, cool. Good job. Any questions? All right, the last thing I would say for this is if you guys look at the actual question, it said to compare. So technically, we actually just made separate descriptions. We actually didn't do any comparison. So if you have a question that asks you to compare, make sure you use comparison words like higher, lower, more than, greater than, okay? But you still run through SMUX, right? So my final answer to this would be something more like this. It would be, the histogram for the age of female heart attack patients is unimodal and skewed to the left, while the histogram for males is unimodal and symmetric. The center for the age of females is higher than males at about 75, while for men, the center is approximately 70. As for spread, the range of the ages of female patients is about 70 years, as well as for men. So that's how I would actually compare two histograms. You go through SMUX at the same time using comparison words like higher, lower, same. All right. Good job, guys.